let's say you want to take the derivative of a composite function. So function in the form y equals f of g of x, where f of x is some outside function and g of x is some inside function. An example of this would be if you have y equals sine of 3x squared. Sine x would be your outside function, so your f of x would be sine x, the outside function, and your inside function, g of x, would be 3x squared. So how could we take the derivative of such a function? Well, this is a pretty ugly big chunk, so why don't we split that, not split it, why don't we assign a variable to g of x to make it look a little bit simpler. So let's say, why don't we let v equals g of x? So now we can rewrite the function as y equals f of v. Now how do we take the derivative of this? Well, we want dy dx, so we differentiate both sides with respect to x. So we get dy over dx is equal to d dx of f of v. Now d dx of f of v. d dx of f of v doesn't become f prime of v because you're taking the derivative with respect to x while you have a v in here. So how could we fix that? Well, you know that d over dx can actually be split into d over dv times dv over dx. And the reason for this is because you could potentially cancel these two dv's and you get your original d over dx. So why don't we split that out? We get d over dv of f of v times dv over dx. So d over dv of f of v, well, that's just the derivative of f of v, or f prime of v. And what's dv over dx? Well, up here we let v equals to g of x. So if we take the derivative with respect to x on both sides, we get dv over dx is equal to just g prime of x. Oops. Oh, there we go. So this chunk here is just equal to g prime of x. So why don't we write that here? Times g prime of x. Now your v here is just equal to g of x, right? Because v equals to g of x. That's what we defined up there. So this becomes f prime of g of x times g prime of x. And this is called the chain rule. So dy dx. The derivative of a composite function is the derivative of the outside function, plugging in the inside function, times the derivative of the inside function. So let's try to apply this to our original example of y equals sine 3x squared. So y prime, or dy dx, would be equal to, and the derivative of the outside function, which is sine x, would be cosine x. So cosine, and then remember we take the inside function and keep it the same. So cosine of 3x squared times the derivative of the inside. The derivative of 3x squared is, well, you take down the 2, so it becomes 6x to the power of 1. Or you could rewrite this as 6x times cosine of 3x squared. And this is called the chain rule. So chain rule